Hi girls, this is the video for 4D, area of special quadrilaterals. So there are three quadrilaterals we're going to talk about. Quadrilateral, first of all, means four-sided. So I'm going to highlight some of the vocabulary words. So quadrilateral just means four-sided. So these are all four-sided figures. And there's another special word here. This first one, area of a parallelogram and beyond, talk about perpendicular height. Okay, so let's talk about what that is. First of all, this is a parallelogram because this side's parallel to this side and that to that. So opposite sides are parallel. Then they put this little dashed line, which is the height, and it makes it perpendicular. So what they're saying is you can't just connect two sides with any old line. That's not perpendicular. Perpendicular means that they meet at a right angle. Okay, a right angle. So it's kind of the shortest distance between the two sides. So I'm going to erase this one because it's no good. And so the height is the measurement that connects the two sides. It could have been these two sides as well, but connects the two sides and meets at a right angle. All right, and so the area for a parallelogram is base, so this side, times height, this side. So the base and the height that connects the two kind of base lengths. Okay, a rhombus or a kite, they're two different things. They have diagonals. Here they go from one, this is also a parallelogram, by the way, but it's a different formula. You could use that formula if you were given it, but these guys have diagonals. And for either a rhombus, which is kind of a square pushed over on one side, so all sides are equal. You can see the little ticks there. So rhombus or kite. Rhombus, all sides are equal, and a kite has two sets of equal sides. So this side's equal to that side's equal to that side, but none of them are parallel. Okay, none of them are parallel like these or these. All right, so in both cases, it's 1/2 the area, 1/2 times one diagonal times the other diagonal. Same, 1/2 times one diagonal times the other diagonal. They just moved these out here, but it's just those lengths there. That x is that length there. Okay, the area of a trapezium. Trapezium has one set of parallel sides, and the other two sides don't have to be parallel. They're not. Okay, and so it's a bit of a different one. We call these parallel sides bases. Or at least they are in my world. And so I add one base plus the other base, a plus b. I multiply that by the perpendicular height between them, making a right angle, and then I multiply by 1/2. Okay, so let's do these examples. I think I'm going to use a pencil even though it doesn't show up as well. This one is a parallelogram, so I know that the area is the base times the height. So the area equals 3 times 8, or 8 times 3, whichever way you want to write it. So it's 24 meters squared. Now we're in area now, so we have square meters as our answer. This one is a kite, and a kite is one diagonal times the other diagonal. So it's area equals, and I'm getting the formula from up here, is 1/2 one diagonal times the other diagonal. Okay, so if I multiply 1/2 times 10 times 20, I get 100. Okay, centimeters squared. Might want to do that on your calculator, but I think you can do this. And then a trapezium area, and I get that just from right here. The area equals 1/2 times the two bases added up. It's kind of the average of the sides of this thing. So 3 plus 11. And then I multiply that by 5. So remember, this is adding, this is timesing. So I get 1/2 times, that looks like 14 there. So 1/2 times 14 times 5. So that would be 1/2 times 14 is 7. 7 times 5 is 35 millimeters squared. And that's it.